Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Hanim Rahman. We are from UiTM Pulau Pinang. My team members are Marina, Noor, Aina, Mawardi, Muhammad Syafiq, Rahman, and Zarina, Mawardi. Our exploratory research title is Floor Plants, Leaf Shape, and Phyllogatis rotundifolius, Soil Organic Matter in Kuala Kenyam Trail, Pahang National Park. Pahang National Park is one of the oldest and most complex ecosystems in the world, and Kenyam Forest is a part of this complexity. Unfortunately, not many studies have been done related to the geometrical shapes of the leaves along the Kenyam Forest and the SOM of the soil along the trail. For that reason, we aim to explore in terms of two main objectives. One, to document geometric shapes or aspects of the leaves in Kenyam Forest because there is near to none current information done on the aspects along the trail. Second, to study about the soil organic matters SOM of the herbal plant known as Phyllogatis rotundifolia, or we call it Tapak Sulaiman, for its medical purposes and traditionally used to relieve gastrointestinal problems and fever. Our study covers data from the Kuala Kenyam Forest located at Pahang National Park, Malaysia, as shown in the slide above. For sampling design and methodology, we focus into two parts. First is the plant geometry photo collections, where we collect randomly along the Kuala Kenyam Trail, and leaves were photographed from different angles to obtain the shapes and leaf arrangement patterns. We use a digital single lens reflex DSLR camera and also mobile phone digital cameras. Second is the samples of soil collected from 4 locations marked A to D along Kuala Kenyam Trail, which started from the UiTM Perkhidmatan Research Centre station to Gua Luas with a distance of 4.2 kilometers per way. The sample we dug by depth of 0 to 15 centimeter from the forest floor surface, filtered and labelled. The soil taken from the 4 locations from A to D were analysed by using the Walkley-Black WB titration methods, where the oxidation of organic matter by potassium dichromate sulfuric acid mixture followed by back titration of the excessive dichromates by ferrous ammonium sulfate were monitored. Hundreds of pictures taken during the expeditions, we later categorized them into 30 distinct leaf-shaped samples. All the 30 samples were then categorized by following Zhang 2020 guidelines and were divided into 10 categories, either by its single leaf shape or compound several leaflets shape. 9 out of 30 samples of leaves fell under the lanceolates category. These are the pictures of the 30 samples classified into 3 categorical leaf shapes, which are linear, lanceolate, and ovate. These are the pictures of the 30 samples classified into another 7 categorical leaf shapes, which are obovate, oval, elliptical, lobed, pinnatissect, chordates, and lacinates. This study found that location B and D contained high percentage of SOM compared to location A and C, whereas location A near the UiTM Research Centre showed the lowest organic matter. Our location indicates slightly acidic soil with pH values ranging from 4 to 5. Acidic soil shows that the soil in the Kuala Kenyam Forest contains a relatively high iron content. Other material content, such as carbon and phosphorus, can also prejudge soil acidity. Finally, we would like to conclude that the Kuala Kenyam Forest Expedition at Pahang National Park served as an initial platform and groundwork. This is just an exploratory study in order for us to document the diversity of shape of leaves in Kenyam forest plants. Next, 30 types of leaf shape were documented with 10 different categories. This data on these leaf shapes that were gathered during this expedition will develop specific documentation on the specific of shrubs and herbs that grew in the Kuala Kenyam rainforest floor. This data can also assist other researchers in anticipating similar species that may be found in other rainforests throughout Malaysia. SOM indicates that the soil in Kenyam Trail is slightly acidic, which is between 4 to 5. This might cause fertility and production problems, but obviously it suits the growth of the tapak sulaman plants. The percentage of SOM and pH value can also support previous studies carried out by other researchers. We also would like to recommend for future works. So in order to successfully complete this exploratory study in leaf shapes and soil organic matters, an image processing method through mathematical calculations and modeling, also by using the artificial intelligence AI, should be carried out. This documentation will not only help botanical researchers but also other researchers such as AI engineers and mathematicians in the future. We would also like to thank the staff from Perkhidmatan Taman Negara Pahang for their guidance, IRMI UiTM for supporting us financially, and to both reviewers for their sincere comments for the betterment of this research. Thank you. These are our list of references, and with this, we end our presentations. Thank you very much for your attention.